You know that feeling? Your phone or your smartwatch has this gorgeous, buttery smooth screen that can stay on all the time. But the battery doesn't die by lunchtime. How does that even work? Well, today, we are peeling back the glass to look at the invisible tech that makes it all possible. It's an ingenious bit of engineering called LTPO.
First things first, let's talk about the fundamental problem that pretty much every device maker, and let's be honest, every one of us has been dealing with for years. It's this constant battle between what our eyes love to see and what our poor batteries can actually handle.
I mean, this is the classic dilemma, right? You get that new phone, you flip on that glorious 120 Hz high refresh rate mode, and wow, everything is just incredibly fluid. But then, you start watching that battery percentage just plummet. It really feels like you have to make a choice, a fantastic experience, or a battery that actually makes it through the day.
So here's the twist. The real culprit here isn't the beautiful OLED pixels that you're looking at. Nope. It's the hidden layer of circuitry behind them, a thing called the backplane. You can think of it like the screen's entire nervous system. It's this complex grid of microscopic transistors that tells every single pixel what to do, when to turn on, when to turn off, how bright to get. And that is where the real energy drain happens.
Now, before our current solution came along, manufacturers basically had two main choices for that backplane tech. On one side, you had LTPS. LTPS is fast, like really, really fast. It's perfect for pushing those high refresh rates. And on the other side, you had IGZO. IGZO is incredibly efficient. It barely leaks any power, which makes it awesome for just showing static images without wasting juice. Two great technologies, sure, but each one had a pretty big trade-off.
The huge problem with LTPS, the tech that was in most of those early high refresh rate screens, can be boiled down to a pretty simple idea. It has a leaky capacitor problem.
So how does this leaky capacitor thing actually work? Well, think of it this way. Each pixel's brightness is held in a tiny little capacitor. With LTPS, the transistors that are supposed to be off aren't perfectly off. They have these microscopic leaks. And these leaks are constantly draining that capacitor, which makes the pixel start to dim. So to stop the whole screen from fading, the system has to refresh it constantly. We're talking 60 or 120 times every single second, even if you're just staring at a photo. It's like leaving your car's engine revving at 5,000 RPM while you're parked. Just a huge waste of energy.
So the big question was, how do you get the amazing speed of LTPS without that fatal battery-destroying flaw? Well, that's where our hero technology comes onto the scene.
So what is LTPO? It stands for low temperature polycrystalline oxide. But honestly, the name is not the important part. What's absolutely ingenious about it is that it's not some brand new material. It's a hybrid architecture. It cleverly takes the two technologies we just talked about, LTPS and IGZO, and combines them on a single display to get the absolute best of both. Here's how that works. LTPO gives each type of transistor a very specific job. The fast LTPS transistors, they handle the heavy lifting. They're the driving transistors that deliver the high current you need to light up a pixel. But then, the super efficient IGZO transistors are used as switching transistors. Their only job is to turn the pixel on and off, and, this is the crucial part, to stop that power leak.
And this super clever division of labor creates what you can really think of as a perfect gatekeeper for every single pixel on your entire screen.
Okay, let's walk through it. Step 1. The LTPS transistor does its job, driving the pixel to exactly the right brightness. Then, step 2, the IGZO transistor steps in, acting like a gatekeeper. Step 3, that IGZO gate slams shut, completely sealing off the circuit and stopping that leaky capacitor problem dead in its tracks. And with that leak totally plugged, the pixel can hold its charge for a much, much longer time, and that means the screen doesn't need to be constantly refreshed anymore.
As faceofit.com puts it, this gatekeeper function is everything. By perfectly isolating that capacitor, it allows the display to do something that was pretty much impossible before. It allows the refresh rate to drop all the way down to just 1 Hertz. That's 1 refresh per second, not 120. When you're just looking at a static screen like you're always on display, the power savings from this are just absolutely massive. So this new hardware capability isn't just some technical party trick. It completely unlocks a much smarter way for our screens to behave, and that translates directly into longer battery life for us. See, this ability to go from super high to incredibly low refresh rates is the secret sauce behind something called True Variable Refresh Rate, or VRR. Unlike older screens that could maybe switch between a couple of fixed modes, LTPO allows the screen to dynamically match its refresh rate to whatever is on screen, moment by moment.
And you can see just how quickly this idea caught on. The whole journey started on our wrists with the Apple Watch back in 2018. I mean, the perfect device for this kind of tech. Then, by 2020, it made the jump to flagship phones like the Galaxy Note 20 Ultra. And now, it's pretty much a standard feature on most high-end devices.
And this chart really shows you the real-world difference. Look at static content like an always-on display. A traditional LTPS screen is just guzzling power. But with LTPO, that power consumption plummets to very low levels. Even for something like browsing the web, where you're scrolling and then stopping to read, LTPO gives you a huge advantage by dropping the refresh rate the instant you stop moving.
Okay, so let's bring it all home. What does this actually mean for you? Well, for one, it means always-on displays are finally practical. You can just glance at your device for the time or notifications without totally killing your battery. It also means just plain longer battery life overall. We're talking savings anywhere from 5 to 20%. And you still get that perfectly smooth experience because the screen can instantly ramp up to 120 Hz for scrolling and then drop right back down to 1 Hz for reading, all without you ever noticing it happening.
The adoption has been incredibly fast, but this is really just the beginning. So where does this technology go from here? What does it mean for the future of all the screens in our lives?
Well, according to market analysis from Omdia, the future is pretty clear. By 2031, LTPO OLED displays are projected to be the majority player in the smartphone market, finally overtaking the older LTPS tech. So this isn't just a niche feature for expensive phones anymore. It's on track to become the new standard.
But, and this is a really critical point to understand, having the LTPO panel is only half the battle. To get the absolute best performance, you need a deep, symbiotic connection between the display hardware and the device's software.
This quote really just nails it. A manufacturer can put the most advanced, 1 Hz capable panel on a phone, but it's the operating system that makes the final call on when to actually use it. And that's why two different phones with very similar LTPO panels can have totally different battery performance. It all comes down to how smart the software is at using the hardware's capabilities.
LTPO is just a perfect example of an invisible technology that fundamentally makes our daily experience better. It really makes you wonder, right? As our devices get smarter and smarter, what other brilliant, hidden innovations are working just beneath the surface to make everything better, faster, and more efficient? Thanks for joining this explainer.